Alright class, welcome to the normal distribution problems by hand video. This is going to be a little bit more in depth because we're doing everything by hand, but I believe we'll be able to get through it and you'll be able to see multiple ways of solving your problems. Let's begin. Find the probability that x is between 160 and 220 of a normally distributed variable with mean 200, standard deviation 25. First thing I would do is draw your picture, okay? So you want to draw your picture with 200 in the middle, 220 over here, and 160 over here. Okay. Then I wanted to find the probability that x is less than 220. Okay. Now we didn't do it this way in class, but I'm going to show you that you can show in terms of a formula what you would do. Okay. So this is an inequality. With an inequality, I can do anything to one side as long as I do it to the other side. So that's the probability of x minus some value. In this case, I'm going to call it mu. I haven't changed anything. I've subtracted the same value from both sides. Now, when it comes to dividing, as long as I divide by a whole number, or a positive number with an inequality, I don't have to switch the signs. So since the standard deviation is, in fact, a positive value, I don't have to worry about switching the sign from less than to greater than, and that gives you another equivalent term. Now, if you look at this left side here, x minus mu over sigma will actually simplify to a z variable. On the right side, we want to plug in the numbers. So you have 220 minus 200 over 25. And I have my trusty calculator here. So 20 divided by 25, I actually don't need that. That's 0.8. So we know that by heart. So the first part is probability that z is less than 0.8. We can grab our table and look up that number. Okay. The other part of this, I'm going to go to the next page, so hopefully you remember we're looking for 160 at this point. So first, z is 0.8. So let's go to the next page. We have probability of z less than 0.8. Now we're interested in the 160 number, right? So you'll have probability of x less than 160. We'll do our same little song and dance. We'll get to probability that z is less than 160 minus 200 over 25. This is now negative 40 over 25. I have my calculator here, and that's 1.6. So now we need the probability that z is less than negative 1.6. So the numbers we're looking for are 0.8 and negative 1.6. So let's grab our table. If you grab your table and you're looking at the positive number, you'd find that at 0.80 you should find 0.7881. This is 0.7881. And if you look at your negative table and you're looking at negative 1.6, you should find 0.0548. And so the answer to your question is just the difference of those two. So you'd have 7881 minus 0548, which will give you something. I don't have it in my hand yet. 7881 minus 0.0548, 7333. Okay. And we put a box around it. Okay. So the next slide, blank, another blank page. Don't need to. But if you look here, this is something I just grabbed offline for 1.6. No, was it 1.6? I think we were negative 1.6 and 0.8. So 0.8 number you'll see is here. Okay, just want this, and the 1.6. Negative 1.6 you would have found here, 0.0548. So we just subtract the two, and we get the answer we're looking for. Okay? Next question. Find a probability that's greater than 240. Okay? I am going to draw my picture again. I always start with my picture. 200's in the middle, 240's over here. This one's much simpler actually. Okay, I want what's greater than it. I know that z would be 240 minus 200 over 25. We just got that number, which is 1.6. This time it's a positive 1.6. So if I looked in the table for a positive 1.6, I see what's less than it is 0.9452. So this area here is 0.9452. So I need to subtract that from 1 to get the number I'm looking for. So the probability that x is less than 240, oops, sorry about that, actually when it's greater than 240. Okay, so the probability that x is greater than 240 is 1 minus 0.9452, which would look to me like it would be 0.0548. And I would put a box around it. Okay. So you'll see again the number I'm looking for is 1.6. If you look at 1.6, you'd see that number, but that's everything that's less than it, so I would need to subtract that from 1. And we did not on this page, but if you just wanted to think about it, negative 1.6 is right there, 0.0548. I could have read it off, and I'd have been done. Okay. Questions? I don't know why I asked you that, because you can't tell me if you had a question anyway. So let's keep on moving. The last question is less than 150. I think it's probably common for you now. I have 200 in the middle. I have 150 out here. The probability that x is less than 150 equals the probability that z is less than 150 minus 200 over 25, which is equal to the probability that z is less than negative 2. If you look at your chart for a negative 2, you will see 0.0228. So this area here is equal to 0.0228, and we put a box around it. Simple enough. Okay. So once again, what do? Number 1, we draw a picture. Number 2, we wrote down our equation. Number 3, we plugged in on the right side for the values, and the left side became a z, and then we just grabbed our table. Okay. And so if you looked at negative 2, not on the chart, you'd find it as 0.228. Number 1. Here's another question. This is question number 2. Okay. So we have these monitors, and they're known to have a normal distribution lifespan of 15,000 mean. Standard deviation is 2,000. What's the probability that it will last less than 12,000? Okay. Just for the sake of convenience, I'm not going to put 12,000. I'm just going to remember that I have 2 zeros behind when I plug in. Okay. So I need to do a picture. The middle I know is 15. 12 is to the left. I want what is less than it. So I basically just want to read off one number, right? So probability of x less than 12,000 is equal to the probability that z is less than 12,000 minus 15,000 divided by 2,000. And the way I calculate it, 3 divided by 2 is negative 1.5. So it's the probability that z is less than negative 1.5. And when you grab your table, you will see 0.0668. And you'd put a box around it. Okay? And I'll show you negative 1.5. This is the positive. Negative 1.5 is here. 0.0668. Okay? But we do have a question about if it's more than 18,000, more than 18,000, probably ad nauseum now. Draw my picture. 15 is here. 18 is here. I want what's above it. I'm going to stop now and tell you I'm going to cheat a little bit, because I noticed the first one we did was 12,000, which is exactly 3 less than 15. And this one is 18, so this is 3 more than 15. So it's the same z-score, it's just a different sign. I mean, I could go through the steps and show you the probability that x is greater than 18,000 is equal to the probability that z is greater than 18,000 minus 15,000 divided by 2,000, which again you get to z is greater than 1.5. Well, I know that if z less than negative 1.5 is 0.0668, by the fact that it's a normal distribution and it's symmetric, this is also 0.0668. I love it when it's nice and easy for me. You put a box around it. Okay? And in this case, 1.5 again would be the 1.5 is here, and that's for the negative, but it's symmetric. So it means it's the same amount as what's here, which is what I like. That's the weirdest looking smiley face, but you get the point. Okay. One more. What about if it's between 13 and 17? Okay. Those are on both sides of the 15,000. So I'm going to show you a hint. And I'll do it both ways, but I'll show you something. If I have the same distance, oh, never mind. We don't need to do that. We'll just do it this way. I want what's in the middle, so I'll subtract off 17, and I'll subtract 13 from it and end up what's in the middle. Another way you could have done that, though, is if I have my distribution, and I know I'm symmetric about the middle, if I had a table that told me the area in between 0 and z, I could take that table and multiply it by 2, and that would be my answer, 2a. Unfortunately, our tables do not give us what's in the middle. They give us what's to the left in each case, whether or not it's positive or negative. So that's why I said, never mind, we'll just do it the regular way. Okay? So I'm actually going to need a paper this time. So remember, we have 2,000 standard deviation, 15,000 mean, 13,000, 17,000. Okay? Skip that. So I have a mu of 15. I have a sigma of 2. I have an x1 of 13. I have an x2 of 17. Okay, so the probability, where should we start? Let's put it here. Probability that x is less than 17k equals probability that z is less than 17 minus 15 divided by 2. Okay, that gives you 1. Probability that z is less than 1. And we know one standard deviation is about 68% in between, which means that when you look at your table, and now look at the positive table 1.0, you have 8413. Okay? 8413. It's half of the data from negative infinity to 0, and then there's another 34% to get to 1. And the funny thing is, when you look at the negative part of that, so x is less than 13, you can follow the math here and see that you'll end up with probability that z is less than negative 1. Okay? And then again, when I look at the table, you'll see that at x equals negative 1, you only have negative 0.1357. That's the area that's to the left of negative 1. So we can draw it again if you want to. At 17, at 13, this area is 8413. And this area is 0.1357. And I need to actually subtract those to get my answer. 8413 minus 1357. Something I do not have memorized, so I'll grab my calculator. And I see 8413 minus 1357, 7056. And I'll put a box around it. Okay, so if I'm not mistaken, that's all the questions I had, but I still have 9 slides, so I'm not quite sure what else I have in here. Let's keep going and see if there's anything else in these. Oh, yeah. Okay, these are more difficult questions. We're not going to bother ourselves with those right now. So, yeah, that is doing the normal distribution that we've seen previously done by hand. So, hope you enjoyed it. I will talk to you soon, either looking at the ones that are averages, or I'll show you what else is here. Okay? So have a good day. Talk to you soon.